Welcome to Study Loop.
Hello friends, here it is given. An ideal gas refrigeration cycle having air as working fluid we have to calculate a rate of refrigeration, net power input, and coefficient of performance. Analysis using table A17, writing fluid property. Temperature T1 is 280 Kelvin, and at this temperature enthalpy of air is 280.13 kilojoule per kg, and pressure ratio is 1.0889. At temperature T3 to be equal to 310 Kelvin, enthalpy to be 310.24 kilojoule per kg, and pressure ratio to be 1.5546. So pressure ratio at state 2, P2 upon P1 into PR1, 160 upon 35 into 1.0889, that is 4.978. So at pressure ratio 4.978, temperature T2 to be 431.5 Kelvin, and enthalpy to be 432.96 kilojoule per kg. At state 4, pressure ratio to be P4 upon P3 into PR3, 35 upon 160, 1.5546, that is 0.3401. So at pressure ratio 0.3401, temperature T4 is 200.6 Kelvin, and enthalpy of the fluid to be 200.57 kilojoule per kg. So rate of refrigeration we can find to be mass flow rate into amount of heat transfer at low temperature, that is H1 minus H4, Mass flow rate is given in the problem: 0.2 kg per second into 280.13 minus 200.57. So it is 15.9 kilowatt. The power input is determined. V net in will be power input of compression minus power out of turbine. Power input of compressor is defined as mass flow rate into change in entropy from state 1 to state 2 minus mass flow rate power output of turbine mass flow rate into change in entropy from state 3 to 4. Substitute the value: 0.2 into 432.96 minus 280.13 minus 0.2 into 310.24 minus 200.57. So it is to be 8.64 kilowatt. Coefficient of performance of refrigeration is defined as rate of transfer of heat at low temperature to total work input. So it is to be 15.9 upon 8.64, that is 1.84. That's all. Thanks for watching it.